Hey guys, we are going to do a station review again for the test, and we're going to have two stations. This time we're going to have a station for proofs, and we're going to have a station for reviewing equilateral and isosceles triangles. So the first one we're going to do is practicing proofs. Now proofs, for many of us, are not that difficult, but we do want to make sure that we're writing down all the steps. Remember, it's like making brownies with a 3-year-old. You have to do every little step. So all we always do is, what do we have? We're given midpoints. Where do we want to go? We're going to triangles, so we know we're going to use one of our 5 methods. We know we're going to use side, side, side congruence. We know we're going to use angle, side, angle congruence, or side, angle, side congruence, angle, angle, side congruence, or hypotenuse, leg congruence. So we want to make sure that we use one of those so that we know it's going to be one of our reasons for this. So we start with what we always do is we start with our given. And we always make sure we mark it in our diagram as well. So J is the midpoint of segment ML, and it's also the midpoint of segment IK. So if I give you a midpoint, what do you give me? You give me 2 congruent segments. So I know with ML, we're going to have these 2 segments, and then I know with IK, we're going to be given these 2 segments that we're working with. So we have 2 pairs of congruent sides. Now we have to physically put those in our proof. So we have segment MJ is congruent to segment LJ. And you can also put the next one in the same spot or separate steps. That's really up to you if you want to do that. IJ is congruent to segment KJ. And so that's just definition of a midpoint. Now, you could also say if you have a midpoint, then 2 congruent segments. I'd be just as happy. So now I have 2 pairs of congruent sides. I've used up all my givens, so now we go to our diagram. You may not assume that these 2 segments are congruent. You can only assume what we know. And one thing we know is that we can't assume our vertical angles. So I know that these 2 angles, my vertical angles, are congruent. As a result, I know the 2 triangles are going to be congruent by side. Let's see if this will go here. Angle, side, because the angle is included between the 2 sides. So let's get those 2 steps down. So now I'm going to have angle IJM, you must name it with 3 points at this point, is congruent to angle LJK. No, actually we're going to go KJL, excuse me. KJL. I want to matchy right away, so I want to be careful. So we have our vertical angle theorem. Okay, good. Now we have our 3 pairs, 1, 2, 3 pairs of congruent things that we need to prove triangles congruent. So we can now do our therefore statement. So therefore, triangle MJI is congruent to triangle LKJ. And what's the reason for that? Side, angle, side congruence postulate. So pretty easy on that one. So not a hard theorem to do. So let's look at our next theorem. Theorem number 2 here. It's the following. It says segment AB is congruent to segment CB. I also know angle 1 is congruent to angle 2. And I want to prove that this smaller triangle is isosceles. Well, how do I do that? If where I want to go is the congruent, isosceles triangle, I need to prove that I have at least 2 congruent sides. So my goal is to do that. And now how am I going to do that? Well, this whole chapter has been using congruent triangles, so I'm not going to be able to use a congruent triangle right here, but maybe I can use these 2 congruent triangles to help me with this segment. So let's see how it works. So we start with our given. All right, I'm going to start with AB. It's just going to be congruent to segment CB. And then my next given is the fact I have angle 1 is congruent to angle 2. And that's also given. And you can put those in the same or separate steps, but I'm going to make sure these are clearly marked. Okay? So I know those 2 are congruent to each other. Now I'm thinking, okay, I would probably like to prove two triangles congruent. So looking at these two triangles and the ones that I can work with right now, is there anything else congruent? Because I've used up my given. And the answer is yes. And most of you are really good at finding these. You said segment BM is congruent to segment BM. You can say MB if you wanted to. And that's just using the reflexive property. And yes, I do expect you to say the word property after it. Now, what do I know about triangle ABM and triangle CBM? They're what? Congruent. So, okay, I know triangle ABM is congruent to triangle CBM by side, angle, side congruence. So the good thing is I know those two triangles are congruent. As a result of those two triangles being congruent, I know that my two line segments, excuse me, of course I know the triangles are congruent, the two line segments are going to be congruent because, what's the reason? You could just picture me singing and dancing right now. That's right, corresponding parts of congruent triangles are congruent. So let's write it down. So we know segment AM is going to be congruent to segment CM. Why? Corresponding parts of congruent triangles are congruent. Now, looking at my diagram, do I have at least two congruent sides for triangle AMC? I do. So therefore, I'm at my therefore statement. So therefore, triangle AMC is isosceles. And the reason why I know that is because I have fulfilled the definition of an isosceles triangle. I have at least two congruent segments. All right, let's finish the next two proofs here. All right, that's supposed to be proved. You can see I got a hole punched out there. But this one should be kind of familiar from what we've had before. So let's make sure we're very careful with what we write down and we mark up our diagrams carefully. I'm going to put the first two givens together. Now, again, I'm just trying to prove the triangle's congruent. So I'm going to use one of my 5 methods that we know for proving triangles congruent. So one of these 5. So the first thing I'm going to do is I'm going to put down all, make sure I have these right. Yeah, I did. The two segments that are pairs of segments that are perpendicular. So I have segment JL is perpendicular, excuse me, to LM, and segment LJ is perpendicular to segment JK. Given. Now remember, if I give you perpendicular segments or lines, you give me what type of angles? That's right, you're going to give me right angles. So I'm going to have an angle right here, and I have one right here, because I tell the way that we said they're going to be congruent. Did I say, yeah. Okay, now let's write those in our proof. So I got angle. You can't say angle L and angle J. There's too many different angles. You have to be specific with your name. So I got angle MLJ and angle KJL are right angles. And so we know that by the definition of perpendicular lines. So we know what perpendicular means. Now, we have to decide if this is going to be hypotenuse leg, or maybe like angle side, or side angle side, or whatever. So it's really hard to do the next step. So you know what I'm going to do? How about we skip it? Let's go and do our next given and see if we get a clue where we should go back here for number 3. So I'm going to go back and I'm going to put my given down. I got segment MJ is, oops, put it down in the wrong spot. White out time to make sure I get this right here. Let's put that in number 4 instead. Hold on. You know this is being recorded very much live here because I am making a mistake and I'm just covering it in front of you guys. Okay. That did not cover well. I'm just going to have to be happy with it. All right. Sorry about that. Let's put our segment down. Segment MJ is congruent to segment KL. And that's given. And I'm going to mark that down right away. So MJ to KL. Now looking at the diagram, I realize I have to have at least that third piece of information. And it's not going to be another angle. really all I really see here is the fact that segment LJ is going to be congruent to segment JL. How do I know that? That's reflexive property. Now I want you guys to look at this. Remember, I skipped step 3 for just a moment because I know the angles are going to be used, but I just marked that's congruent. If I do this carefully, notice what that spells. Side, side, what? Yeah, I did that real light angle. And do we use side, side angle? No, not unless it's a right triangle. Or are those right triangles? Yes. So instead, really what we're using is going to be hypotenuse leg. That means I have to state that the triangles are right triangles here. So I'm going to go triangle, JLM, and triangle, LJK. That's an and symbol there. Someone asked me if that was a plus sign earlier. Are right triangles. And that's just the definition of right triangles. Because remember, I have to have it mentioned that's a right triangle or I can't use hypotenuse leg. So now I actually have all the pieces I need. I have hypotenuse, I have a leg, and I have a right triangle. So therefore I know triangle JLM is congruent to triangle LJK by hypotenuse leg congruence. All right, last proof. All right, we have perpendicular segments again. I also have M as the midpoint, and I want to prove that two segments are congruent, okay? So if that's the case, I need to remember that this whole chapter again is like, how am I going to get there? I'm going to prove congruent segments. Well, I'm going to use the fact that corresponding parts of congruent triangles are congruent. I'm going to have to prove triangles congruent somewhere. So I start like any other ones. We start with putting our given down, marking it up, and putting it in our proof. So right away, I'm going to do my two sets together again because I want to put them here. I got EC is perpendicular to EF. Remember, EC to EF, so I know that right angle is going to be there. I got segment EC is also perpendicular to segment AC. Given. Now, if you want, you could just use that and you're not going to have to worry about anything else. To be honest, you just won't have to. Or some of you are sitting there thinking, well, I can prove some lines are parallel, so I can go with angles. You can use that as well. So you could have a different proof than what I have here. So just come talk to me if that's the case. But I also know when I have perpendicular line segments, I have to have the angles. So I know angle E and angle C are right angles. All right, so that's definition of perpendicular lines. Notice, like just up above, same start. I have the fact they're right angles. But this time, just because I know where I'm going with this one, I'm going to go, okay, I'm going to say they're congruent. So angle E is congruent to angle C. All right angles are congruent. So with that, I then go back to my given information. So I got M is the midpoint of segment EC. All right, so that's given. And remember, if I give you a midpoint, what do you guys give me? That's right, two congruent segments. So I got segment EM is going to be congruent to segment CM. So what does that give us? Definition of a midpoint. Okay, so looking at that, what's given to us in our diagram? I was skipping ahead again. I have an angle and I have a side, so I either need another pair of sides or another pair of angles. So looking at the given information, what's the one thing I could assume and get away with for my diagram? That's right, my vertical angles. So on here, I got my angle EMF is congruent to angle CMA. And that's my vertical angle theorem. Now, after that, notice I end up getting an A. So how are those triangles congruent? That's right, by angle, side, angle. So my next step, I'm going to get triangle EMF is congruent to triangle CMA. And that's going to be using angle, side, angle, congruence. Now, because those two triangles are congruent, what can I assume about segment EF and CA? That's right, they're congruent. So therefore, segment EF is congruent to segment CA. Why? Because corresponding parts of congruent triangles are congruent. All right, guys, I hope that helps. These are more practice. Remember, you got 2 on your proofs. They should also help you as well. All right, good job.